Hello all, welcome to my YouTube channel. Today I'm going to discuss on natural language processing. Natural language processing is an intersection. NLP focus on interaction between computers and human languages, which enables machines to understand, interpret and generate human language in a way that is both meaningful and useful. It tries to analyze and process text data or voice data and grasp the meaningful, and it also includes speakers or writers intention and emotions. NLP can be applied in many applications such as language translation, voice recognition, text summarization and chatbot. NLP plays a major role in machine learning, deep learning and generative artificial intelligence. Now let us look into the task and applications of NLP. The tasks are divided into core tasks, general application, and pre-processing, text representation, feature selection, model selection and training, model deployment and inference, evaluation and optimization, and the final step is interaction and improvement. Let us look into these 8 steps in detail. The first step is text input and data collection. When we want to perform a task with respect to NLP, we need some data, and those data can be collected from a website, or it can come from a book, or it can come from a social media or any proprietary databases. So these data, once we collect it, we are going to store it in an either in a structured format, or it can be a collection of document. And moving further, these steps are text pre-processing steps, where it starts try to clean the data and will be able to do further steps. So the first step is tokenization. In tokenization, where when we give the entire document to an NLP task, first step is to divide that into words. Say when we give a paragraph will be divided into sentences, and sentences will be broken into words. Even this is not a simple task, because say for example, where we have a name called Mr. Dot and something else. So how do this NLP identify a word separately, or how do I break a sentence? Here I'll either use a question mark or a dot as an indicator to segregate a sentence. But as we have seen, Mr. Mr. Dot, it will not treat Mr. as a particular sentence. So it is able to do on its own. So the first objective is that we are going to break the entire document into sentences or into words. And then comes lowercasing. We are going to lowercase all the words that are present in the NLP task. And then we will be removing all stop words, that is, say for example, is, and, that, but. These are words in English known as stop words, which doesn't give any meaning to it. So these words are removed during NLP task. Then comes removing punctuation marks. Once this has been done, then it is given to stemming and lemmatization. So stemming and lemmatization, what it tries to do is that, as we spoke earlier, it will try to find the root form of a given word. As I told you, write, writing and written, the base word is right. Both stemming and lemmatization tries to do this, but stemming stops at it just cuts by prefixes, whereas lemmatization will try to find a meaningful word out of it. When you want to make your system very fast, then you can go for stemming. When you deal with sensitive information, then you need lemmatization as a to find out the base word. Apart from that, you can do a text normalization, because nowadays when we get an information from an social media, we end up with plenty of emojis. So emojis, we are supposed to convert it into a meaningful representation of words, and for that we have a separate technique known as Unicode normalization. So using these steps, we can do text pre-processing. Once text pre-processing has been done, the next step is text representation. For the text representation, why do we need this is that we cannot pass the text as it is to a computer machine, because computer machine doesn't understand any text as it is, because these text has to be converted into some number format. And for that number format, what we are trying to do is that we are using these one of the techniques shown here to convert your text data into a number format. So once uh, that the first technique is one-hot encoding. One-hot encoding is one technique. Then comes bag of words. Then comes continuous bag of words, and fourth is term frequency, inverse document frequency, and word embeddings. Let us look into bag of words. Bag of words, what it tries to do is that it will try to keep track of the word frequency. But here the problem is that it ignores grammars and word ordering. To overcome this word ordering problem, continuous bag of words was introduced. Then comes term frequency, inverse document frequency. As we seen, as I spoke about, one-hot encoding is one technique. It is very basic model. Bag of words. Here there will be a n number of zeros. Only few values will be in terms of ones. Other values will be in terms of zeros. So to overcome, since we are having only zeros and ones, we are not able to find the meaning in a given context. So the researchers have used term frequency, inverse document frequency. So what it tries to do here is that it will try to figure out what is the relative between each words, using again through some number representation. In the upcoming videos, I'll tell you how to do bag of words with an example, term frequency and word embeddings in detail. Since it is an overview class, we'll speak only the basic terms. Then comes word embeddings. Again, the text is getting converted into a vector of words where it will have a similarity. Similar words will be grouped together. Say for example, man and woman will be close together. Likewise, apple and mango will be close to each other. Likewise, groupings will be happen. This happens through word to vec and in glove model. Once we have computed a text to some number format, then we are going to do a feature extraction. So feature extraction is an important uh, task in NLP. This can be done through n-grams, where n-grams will preserve some word ordering in the given context, and it tries to identify syntactic features, that is parts of speech, and then it will try to have the parser trees over there. And then comes semantic features, where it tries to identify the meaning of word in a given context. Once the features are extracted, then appropriate model is being selected and trained. Say for example, if you are doing an classification kind of problem, then obviously we'll be using either machine learning or deep learning kind of models, or any pre-trained models. Say for example, when we have a labeled data, then we can go for supervised machine learning like support vector machine, random forest, decision trees, and so on. And likewise, we can deal the same problem with deep learning models like convolutional neural network and recurrent neural network. When we don't have labeled data, then we can go for unsupervised learning like clustering or topic modeling. When we have pre-trained models like BERT, BAT, GPT, transformer models, that can also be used because these models have been trained with huge amount of corpus, so that can be utilized for our models. Once the model is trained, the next step is that we can go deploy and see how it works for different scenarios. Say for example, it can be applied for a text classification, it can be applied for named entity recognition, machine translation, and question answering applications. So coming to the evaluation and optimization, so we are going to check how well our model is working on real time. So based on that particular thing, we are going to continuously improve it. So when we deploy our model, the model itself can get some input and it can pre-train on it, or else we are going to do a manual training on it. So the matrix here is that we'll be using accuracy, precision, recall, F1 score, blue, and other parameters to evaluate the model, and we'll be keeping track of all these things in the upcoming phases. So if you are going to optimize any features, then we can do it. So depending on our need, we can iterate the data. Once we have iterated, then again it can be deployed into the real applications. So with this, we'll conclude the overview of NLP. We'll see you in the next video. Thank you.